Hi everyone. Today I'll be discussing something about Postgres database. So when I say Postgres database, there is a very good concept in Postgres database called as MVCC, multi-version concurrency control. So I just wanted to discuss this topic, and I just want to show you how the data is stored inside the Postgres and how it is going to deal with the data and all. So for that, let me connect to Putty. Yeah, this is Putty, and but let me take a new tab so that you will not get a feeling that I'm starting it from somewhere. Sorry. So yeah, as this is my local lab environment, I am able to connect to root user. That doesn't mean you can do that in your environment. It's not like that. If it is, yeah, I connected to this one PSQL. I'm simply connected to PSQL. But if you see how I am connected to which database I am connected, you are connected to database Postgres as Postgres user. I don't want to mess up the things in Postgres user, so I'm just going to create something called as test database. So yeah, let me create the database and tell you what we are going to do in detail. So yes, I have created the database and I am connecting to test. So this script I created just before 2-3 hours. So I'm creating a table called banks, and I'm going to show you how MVCC works. I'm going to show you how MVCC works, and also I'm going to show you how Postgres fetch the data. So what is so special in Postgres? There are many other databases. So if you see Oracle database or SQL Server database and all, in Oracle database, what happens is your data, which is being modified, is stored in some other segments called as undo segments and undo table space. So why should you store your data which is getting modified? Because for every RDBMS, or to be precise, any database should obey ACID properties. So in ACID properties, one of the thing is isolation. So keeping the data isolated till the actual data is populated. Like if at all my salary is 3,000 and I want to make it 5,000, and I just simply write an update and it's not final. You have to commit the data. So till the time you commit the data, your data should be somewhere hanging. It should be very isolated so that no one touches it for update. They can read the data, but they should not do it. So for this to happen, Oracle is maintaining something called as undo. SQL Server uses sometimes, most of the times it uses that temporary LDF files, MDF, LDF files. One of those files, test database related, but sorry, temp database related in SQL Server, if I'm not wrong. So now what happens here is like here what I'm trying to do is I am trying to show you something like here there is nothing like another undo or something. Here entire data of your Postgres, isolation is also happening in the same table. Or when it comes to Postgres, you don't call it as a table. To be precise, you call it as a relation and tuple. Yeah, sometimes I might be using table and row. Just you can relate or remap it to relation and tuple. So now what happens is, so I'm just creating this one extension. This extension is just to make sure the below query runs perfectly. So yeah, so there are something like extension in Postgres. Most of the people must be knowing who are already working on Postgres. For the people who don't know, Postgres comes with a basic pack, so you can keep on installing your extensions and you can get much more functionalities. So one such extension is PG free space map. So now I have just created the table and I have seen the size, and if you see, the size is nothing, but I have created the table. Yes, that's true. Now what I'm going to do is I'm just going to check what is the transaction ID on the database. So yeah, it is 859. If you run it again, it is like 860. That is because even whenever you select this one, one of your transaction ID is being used. So now let me begin and insert. So you must be thinking, why should I do begin and insert? Why can't I simply insert? So I just want to make sure all my inserts are having the same transaction ID. So 861 probably, if there is no other transaction happening in the backend. So yeah, so why, if it comes to Oracle, it is auto committed. Sorry, it's not auto committed. It's like if you run only this particular insert in Oracle database, you have to either commit the data or roll back the data. Only then your lock is released or your undo is released or something. But when it comes to Postgres, if you simply run this particular statement, it is directly committed. So to avoid that, I just used begin and and then my inserts or whatever DMLs and then commit. So now let us simply fire a query like select star from banks. I think the data is populated and it's good, right? So let me see that. So is my data really populated into the table? Yes. As I'm committed, yes, definitely yes. And I have 8 rows. So you need not observe the data. It is simple 1 to 8. I have given some IDs and some normal banks which are available from India. Now let me check where this uh, data is stored in the database. So if you try to get one more concept here, in Oracle you have lots of table spaces in which you have lots of data files. So data file is not with respect to a single relation or a table, but it is with respect to many things. Like one particular data file or a table space can consist of lots of table data, but when it comes to Postgres, it is completely different. One particular file at the table space level will have only one table data. So if you see, this bank's data is somewhere here. So let me just replace this and show you what's the size of this in operating system level. That's the reason I was thinking to take second session, but I did not take. Yeah, now it's taking time. Okay, let it take time. So I just want to see, this is, when I say this is base is somewhere in data. So you should know your data directory. Yeah, let me zoom it and clear the screen, and let me simply run this. Not this. I think I replaced it. So if you see the size, it is 8 KB, 8192 bytes or 8 KB. So the table is just created and the size is this much. So as I told you, every table will have a different file. Here, this is my database name, I mean my test database related directory, and 49348 is the file in which my banks table data is stored, and this is the size. But if you see the size here, when I say here, I mean when I say this one, so if I see the size here, you can see that even though at operating system level it is occupying 8K, in OS level it is saying nothing. That is because of the statistics. Your table is correct, but your database is not having the right statistics on the space usage. So for this, what I'm going to do is I'm simply going to do vacuum. I'm going to analyze and verbose. So verbose is just to make sure the output comes, and you will understand what's going on in that vacuum. So see, if you see, as this is a small table, it took lots less time. So vacuuming test.public table and finished vacuum in very short time, and it scanned only one page. So that's because only one page is allocated now. So when will be the next page allocated? Once that this particular page gets, I mean here, let us go here. Let me show here better. So, oh no, there are lots of other objects, but yes. Yeah, these are the files we have. Okay. So these are the files we have. See, this is like mapping and this is free space mapping, but the data is only in this particular file as of now. So if at all this goes to 1 GB, then again another file comes here, and that goes on _1 _2 like that. So that's not our area of interest in this demo today. But so now if you again check the size of the table after the statistics, the size is now clear. So we are not going to remember this, but you can write it somewhere. It is 7840 is the size, and free space in this particular block is 95. So if you see this one, this is block number 0. So you this, if you are keeping on writing the data, your block number 0 becomes block number 1 and 2 and 3 in the same way. So as I told you, after 1 GB is filled, this particular this is completely filled, and another file is created. So we saw the data from the banks here. We saw the data from the banks here, and let me check what are the columns in this. So you already know that I have created the table with only 2 columns. One is ID and the other one is name. But if you see in this table called PG attribute, you know what is an attribute, right? Entity and attribute. So this name is given like that. So every entity will have multiple attributes or properties. So, but here he says there are some other columns like table OID. Yeah, table OID is nothing but this one. Sorry, I'm sorry for that. Table OID is nothing but this one, 49384, something like that. But where am I? Yeah. So what is this xmax? What is this xmin? What is ctid? What is these two? Anyways, you know this. So the thing is, even if you create the table with your columns, there are some system columns. As if in Oracle you have something like row id. In the same way, we have some other system columns here. So there are many more, but I have just selected few of them. So pg attribute is that which gives you. So now what I'm trying to do is I'm trying to create this extension. I think I already created this. Now it's not required, and let me try to get this data. So there is a function called heap underscore page underscore items, which is not by default. You have to install one of your extension for this. So I have created this extension. If you see, this extension is created, and I'm just trying to get the data from this particular this one. So if you observe, my transaction min is 861 for all the tables. When this is nothing but, if you remember here, it was 860 and I started inserting the data and then I committed. So the transaction ID took is 860. So when you insert the data, your xmin is the current transaction ID and your xmax is always kept to 0. So when you see 0, 1, 2, 3, 4, 5, 7, this is the pointer. This is the line pointer, and this can be, it's like internal information about your CID. So you cannot ignore these values for now, but you have to concentrate on this. So your xmin is always the current transaction ID and your xmax is 0. So now let us see some more in this. Let us try to get few more data. So yeah, I'll just zoom out for you. Some more zoom out. So if you see, this is the actual data in your page, even here. So what is this? What does this mean? So when you say banks comma 0, or let me show this one here. So when you say banks comma 0, your banks table might be having multiple blocks or multiple files, data files. So you're just getting it from the first or 0th block. So in the 0th block, what's the data here? This is the data, but you must be thinking, yeah, this LP is nothing but pointer. So I have written here itself. This is line pointer in that particular block. So there can be any number of things based on your row length. So this is your data. So you must be thinking, but where is this /x100? This is not my data. Something like HDFC, ICICI was my data. So, but this is how the data is stored in your page. So I am not trying to get the data from banks. If I get the data from banks, it is completely different. You can see this. I'm not trying to get the data from the banks. I'm instead getting the data from the page. So whatever in the banks page, from 0th page, I'm getting this data. So which is 8k. So this 8k of data, I mean that block data is here. So now if you observe, I mean, we don't want every star records. I'm just trying to minimize the data, and I'm also trying to format my data. If you see formatting my data, see, I'm using this T data, and I'm also trying to get the data in the format which I have inserted. Oh, let me, yeah, there is extra comma here. I'm sorry for that. So let me rerun this query. So if you see, there are 8 records. See, this is your bank ID. Yeah, you must be thinking, how did I encrypt this? Yeah, this is the formula I have used for that. Okay, and this one and this one is not same. Okay, just this is the line pointer of this particular row. So HDFC in that particular page is in the first place, and second page it is SBIH, and then Bank of America, and then SCB, and then Axis, like this. So now let us try to understand one more thing. So let me try to do few deletes or something. So instead of doing deletes, I will simply do update. What I'm trying to do is I'm simply trying to do update this SCB. Instead of SCB, I'm keeping it as Standard Bank. Yes, I should have kept Standard Chartered Bank, but I'm simply keeping it as Standard Bank because I remember my table is being created with varchar 10 or 20. I'm not sure if that is sufficient. So let me go. Yeah, I kept it with 20. Yeah. So this is, I have done an update. If you see, I have done an update. I have updated SCB to a standard bank, and then I have committed the data. Now what I'm trying to do here is, I'm going to do one more update. I'm simply making BOA to bank of A. So as I'm not sure if America is filled here, I'm just keeping it A. I just want to make sure that this is changed. That's it. So but this time I'm not going to commit the data. So I have done some changes. The changes are very simple. Instead of SCB, I have made it standard bank. Instead of BOA, I have done it BO bank of A, but I have rolled back this one. So the only change I have done is this. The net change which I have done is this. So let me get the data from the table. So if I see the data, yes, BOA is as it is and your standard bank is as it is. But if you see the data, why is the fourth record? Earlier, if you go and see here, the fourth record is kept in the fourth. I mean, bank ID 4 is given in fourth place. But when it comes to uh, now, after changing, it says it is listed in the last position. This is because your data is heap. I mean, it's like it's not stored in ascending order, or your Postgres process, server process, will not give your data ascending order or descending order. It simply goes to the block and it simply gets the data. So if you see the line pointer, this is line pointer 1, this is line pointer 2, this is line pointer 3, but this is not line pointer 4. Line pointer 4 is SCB. But when you do an update, Oracle is not simply going to do an update. It's simply going to delete the previous record and inserting the new record. So the fourth line pointer is deleted here and the ninth line pointer is inserted. So let me prove you that. So you saw the data, but let me again run this. Oh, here also I have kept 2 commas. Let us remove this and run this. Done. So now if you see, this is now again, here I am just trying to get the data from the table or relation. But here this query is not going to get the data from the table. Instead, it is going to get the data from page. So now you must be thinking, why 10 records? Because one record which is modifying your Bank of America to BOA and the other record which modified your SCB to standard bank. But as BOA is rolled back, your data did not fetch that. Instead, I mean, it simply gave you this one. So if you try to understand now, this particular 4 line pointer is 9 and line pointer number 4 is not given to you as an output. Yeah, this must be confusing, but the people who are very good into the architecture can easily understand these things. Now, next. So what is Postgres doing in the background? So if this is the physical data, so you must be thinking, why is this data stored? Because before you roll back the data, if some other user tries to fetch the data, he should get this data only. That's the reason why this is also stored, and this is nothing but undo management in Oracle and multi-version concurrency control. So if you have a record getting modified, it should have multiple versions. In Oracle, one of the version will be in undo and the other version will be somewhere in your database buffer cache or your respective data file. But when it comes to Postgres, it's completely different. It is in the same table or in the same segment or in the same data file, in the same block, whatever. So now, so what does Oracle now, sorry, what does Postgres? I will be using the term Postgres, Oracle again and again because that's the database which I have learned very first. So what is Postgres using this to get this data? The filtered data. So is it not getting the data from the raw page? Yes, of course it is getting the data from the raw page. But before getting the data from the raw page, it is checking a column called as tinfo mask. So this tinfo mask is having, if it is committed or something like that, and it is also checking xmin. So it checks xmin, it checks tinfo mask, and in the combination, it has a big logic like this. So it has to check if it is committed is true. Okay, then it's good. And let us check if the transaction ID xmin is perfect, good. If xmin is valid and then this condition is true, good. And also it has to check if xmax is 0, then no transaction has been deleted it. So this is the calculation. You can simply read this multiple times and you can understand what Postgres is actually doing to fetch the only valid data. So if I run this particular query, now this time I'm trying to get the data. I'm trying to get the data from, if you see, I'm trying to get the data from the block, physical block or page, but I'm only getting the actual data in the same format. If you see now, select star from table, sorry, whatever the table banks, that's again the same. So this data and this data is same, but why it is same? Let just ignore the column names and all. Why is it same? That is because of the aliasing. So that is because even though you are getting the data, you are using the same formula which Oracle is using. So what I mean to say here is, when you say select star from banks, it is not simply select star from banks which is getting called. Instead, this is getting called. This is getting called, but it is adding some more conditions to it, and then you are getting the data. So now with this, you must have understood how the data is stored in this one. So now let us see the size. So the size won't be different, but as we have 10 KB, so yeah, 7840. So if you remember in the starting phase, I don't remember the sign, but yeah, it is same 7840, and most probably something like 95% of this particular block or page is free. So now what I'm trying to do is, I'm just simply trying to do vacuum. So what does vacuum do? What does vacuum does is like, so before doing vacuum, let me show you one record, this particular record. Before showing vacuum, let me show you this record so that you'll not be confused a lot. So if you see this, there are 10 records, out of which this is wrong record, out of which this is also wrong record. So except line pointer 4 and line pointer 10, remaining records are correct. I mean to say, only 8 records are correct records. So now what I am trying to do is, I am simply trying to do vacuum. You can simply ignore verbose, and also I am doing analyze. Analyze is just to make sure statistics are also gathered. Now let me check the size of the table. Let me check if there is any difference. Yeah, it is 7808. Earlier it was 7840. Okay, there is no big decrease now, but still, let me again run the same query here and show you the good thing here. So what does vacuum actually do? This is very important. So vacuum, what does it do? See, if you see, the last row, it is deleted because that was never required, and this fourth record is completely blank. So earlier it was SCP, here it was something, here it was something like 3 or something 4, everything is deleted. But if you do the vacuum, that doesn't mean your space is somewhere, I mean, you are able to reclaim the space. No, at operating system level, the space is not reclaimed, but this free space is kept. Then how, when will this be used? If at all this particular block is, or page is completely filled, then this particular line pointer will get some data, so that we can insert and see, but that's not my area of interest now. So now let me just show you. Now you must have understood one thing, that we have something called as table and relation or table, whatever you call it, and the table has some data, and you simply fetch the data from the table, select star from table name, and you get the data. But this data is actually stored somewhere in your data file, and where is the data file located? Somewhere over here, somewhere over here, and the size is clearly shown as 8K. Once this 8K is filled, and again it gets on increase. These things we understood. And the other thing is, when you are doing an update, it is not simply updating that particular existing row, but it is inserting one extra row and deleting the, I mean, it's marking the old record as committed or not committed, whatever. So if you observe these things, uh, now let us now your xmax are also reset. Now let us go and do one thing. So I have just checked the path, and I came to know that is 49384. Now this time what I will do is, like, I will try to run this vacuum full. This time I am running vacuum full. So now let me again try to check the data. So if you see, this is 49348, this is 49399. So it is as similar, vacuum full is as similar as this one in Oracle, alter table, table name, move. So when you try to move the table in the Oracle, it completes the copies into a new location. In the same way, when you try to run vacuum full, the entire data is simply copied and pasted in some other location. So now, but after this is done, so let me check the size. So don't get tensed, your size completely becomes 0. You must be thinking, why 0? Let us see the data, if the data is there in the table or not. So yeah, data is there, but why is it still showing 0? Because your vacuum fill is so efficient that if your data is less than 32 KB, sorry, 32 bytes, then it will show it as 0, maybe because of the rounds or whatever. So you to get this data again, if you want to see this data, you can simply do this one. and you can vacuum and you can again check. So this is the data and this is the size of the table. So it is 7808. So the conclusion is simple. So when you do an update, yeah, let me try to come from the beginning. Though it's confusing, let me try to summarize it. So when you insert the data, so before I inserted the data, I have checked this transaction ID, it was 860. So if there are no other parallel sessions running, obviously my data has got 861. And if you observe, all the xmaxes are 0. But the moment I update the data, where did I update the data? Here I updated the data. The moment I updated the data, so Bank of America, the xmax is changed. So there are two records for Bank of America. So the one has xmax has changed and the other one is a new insert. So this is an update. So whenever you are updating a record, the existing record will be populated with the latest xmax. And this is how it happens, and this happened this one as well. So you must be thinking, so Bank of America is a rollback transaction and SEB is a committed transaction, but we don't see any difference here. Though you don't see any difference there, you see the difference here in T underscore info mask. If you see the data from T underscore info mask, the data will be completely different. So if it is committed, it will be something like 258 and all. So that's a very big principle behind it. So after that, what I try to do is like I try to show you the data from select star from banks, and I also try to show you the data from the page. But this time, while showing the data from the page, I used the where conditions which Postgres internally uses for this particular query. And then I also showed you the data without using where condition. You can see there are 10 records in this particular page, out of which 4th record and 10th record are not required. So the moment I do vacuum, then the records which are not required, or the records which are obsolete or old, are updated with the new values, are simply deleted. The data is deleted here. So when I say the data is deleted, instead of SCB, it has just deleted SCB and it has erased it. And here instead of 4, it has erased it, and here instead of data, it has erased it. And there is nothing like, even though the line pointer is still continuing to be existing, your particular this is not existing, like the data is not existing. So even though the data, now the data is released, and if you see, even though the data is released because of this one, I mean after the delete and vacuum, that is not known to this I mean after the vacuum is done, yeah, this is known to this particular thing, like the space is also released. But later on, I tried to show you the path of that banks. That is just because I showed the path of the bank here, just to make sure after vacuum full, this particular file is changed, because this is like copy paste and then cut the old record. So that's how it happens. It's not copy paste, it's cut. Sorry, it's not cut paste, it's copy paste and then cut. So first what it did is, when you do vacuum, what it did is it took the data from 49348 and it copied the data to 49399. It copied it. So once this copy is successful, internally it then demap this banks table to this. So once that is done, so you must be in a confusion, even though the data is existing, why it is 0. So when you are, because of this rounds and all, and when your data is less than 32, your Postgres is very sharp, that it will compress the data when the data is very less. I mean, that's how it happens. So next, so I am trying to vacuum it again so that you will understand the size of the table, and this is done. So the actual concept starts here, but I know this is very confusing, but I don't want to make this MVCC and the transaction wrap around in the same video. So I'll be uploading one more video where I will try to give you the transaction wrap around, how it works and how it is dealt in the Postgres, and what is transaction wrap around. And to avoid that, we have something called as freezing the transactions. How do we freeze the transactions and all? So yeah, before going into the next video, let me tell you something. Let me compare this with some other database name. In Oracle, we have something called as SCN number, system change number. For every commit or for every transaction, there is a SCN generated. So in the same way, in SQL Server, we have something called as LSN number. For every change or for every commit or transaction, in the simple words, for every transaction, there is a LSN number. In the same way, in Postgres, we have something called as transaction ID. So that transaction ID in Oracle can grow to a bigger number. In SQL Server, it can go to bigger number. But when it comes to Oracle, it cannot go to it cannot grow beyond some number. That is, it starts from 0 and it goes to 2 power 32. It goes to 2 power 32. So when it goes to 2 power 32, once the transaction ID is 2 power 32 value, then again it should start from 0. It's not actually 0, it starts from somewhere around 3 or 4, because 0 is reserved for invalid transactions and 2 was reserved for freezing the transaction and all. So the thing is, just for time being, let us understand my transaction number starts from, loop starts from 1 to 2 power 32. So what happens if my 2 power 32, let us assume I have a table 1 HDFC and xmin is something like 10. After 5 months, my transactions are completed from 1 to 2 power 32. And then now what happened is, I have another record like 101, some other bank like State Street or something, whatever, ANZ, Australian New Zealand Bank, and my xmin can, as it is already rotated, as this is completed, the next thing which happens is, again it starts from 1. So 1 is gone for some transaction, 2 in the same way, 3 in the same way, 4, 5, 6, 7, 8, and 9 are gone from some other transaction. Now for this particular transaction, again I am getting the xmin as 10. So ideally, when you see this data, you feel like this particular HDFC 1 and 101 ANZ is inserted in the same begin. This is what you expect. This is what you, I mean, interpret but this is completely different. And there is another concept called visible records and invisible records. Yeah, all these things I will be discussing in transaction wraparound in the next thing. But just to give you a hands on this, so that you will Google about this thing before watching the video. Yeah, though that is confusing, it's required. And yeah, if the other things, if the things which were there before this one, like some other concepts, if I would have told you, that would be easy to understand MVCC. Directly understanding MVCC is not that easy. I understand that, but try to watch the video again and again and you'll try to get it understood. You can comment in the comment box. So if there are any doubts, I can try to clarify this, and if there are any corrections, I'm open for those. Please correct me if there is any statement wrong. Thank you.